Hello everyone, it's May 11th. We're doing an early one today. Alright, let's take a look. We have a lot of comments here. I don't remember. I don't know where they are. Alright, let's do it. Maximum points you can obtain from cards. There's several cards arranged in a row, okay. Each card has an associated number, okay. Yep. In one step, you can take one card from the beginning or from the end of the row. You have to take exactly key cards. Your score is the sum of the points of the cards you've taken. Given the integer array and the integer k, return the maximum score you can obtain. So on the front or at the back, we take 3 cards. So we take the back 3, yeah? 5, 6, 1, give us 12. However, choosing the rightmost card will maximize your total score. The optimal strategy is to take the 3 cards on the right, giving a total, yep. This doesn't matter which side. This, can we do greedy? Every time we take the maximum, we take here, and then 7, 7, 1, 2, 3, 4, 5, 6, 7. I'll just take all the cards. Take 1, take 3. Well, the first one doesn't matter. We can take either one. Oh, it does matter. Because if I take this one, and then the second one will be taking this, right? It's actually taking these 3, I think. No, actually still these 3. Okay. So, I mean, we have an array, a bunch of numbers, right? And then we can say each time we can take either, greedy might not work, right? It depends on what other cards there are. So this smells like a dynamic programming to me, which we can build up. How do we build up the DP table? We have k. So each time, right? Each time it's either taken from the left or taken from the right, right? It's either that left or either right. So we can choose. Let's say we want to know the maximum of taking k. Let's say the maximum taking 1, right? The maximum taking 1 will be just taking the bigger. That's triple. Now the maximum taking 2, right? The maximum taking 2 will be what? The maximum taken 2 is different, right? Because if we have, say, on the left side of the 1, on the right side of the 10, and then the second one on the left side, it says 100, and on the right side is a 1, right? Let's say if we take 1, we choose 10, but if we take 2, we have to restart. It's an interesting thought. What does that mean? If I take 1, I say we take 10. But if I take the next one, I say we want to take 2. That does not based on the optimal from the previous take. Because the previous take cannot lead to the optimal for the next take. So is this not a DP? Or we have to think about DP another way? I'll try some other methods. So say we take, like here, we take 3, right? So the only possibility of taking 3 will be only possibility of taking 3, either like we can have the end 3 or the front 3, right? This we can compute. And then between these 2, we can have a winner. And then we can lose 1 and include 1. Yeah, so if we have the full on one side and we just lose one, include one, lose one, include one, lose one, include one, and then at one time we will reach the maximum. We go through the entire thing. That means we loop through. We of course we sum it first, right? We sum it first, so that's on. Okay, right? So okay, we sum it up, and then we just going one by one. We remove it, and we add it, and remove it, add it, remove it, add it. Ah, that's about it, right? Let's try it. It's no DP. I think it's just straightforward programming. Oh. All right. Let's see if it's straightforward programming. I think it is, right? I don't think there's any trickery in it. That might be trickery. Well, we'll find out. Right? We'll find out. It's always happened. We always find out the trickery later on. Alright, so my idea is for the k, we first sum up. So say the s is going to sum. Oh, that one's going to do a copy, right? So I probably don't want to do that. That's fine. Let's just do it. Sum card points to k, right? Just go the first k on the left side. And then we have I is equal to k minus 1, right? And j is going to equal to, what's j going to be? J is going to be, j is going to be the end len card points minus 1. Right, j is at the end, and then we just I moving towards the front, and j, and every time we get one, remove one. Oh no, I realized. No. This is not right, because we're saying that the difference between the front and end is only one. We can have. Wait, can we? Hold on. I'm gonna get. Did we include all situations in this? I mean, the only is k, so we have to take front so much and back so much, right? So the front, as we give up on the front, we add it back. We give up front, we add it back, because the sum. Yeah, I think this is right. This is right. I think this is right. So what we do is while I is larger than equal to 0, right? Then we say, well, I is larger equal to 0. I'm gonna say result. Okay, res, right? Res equals maximum res minus card points I and plus card points j. So that's like move 1. Take away the I, and then I and j both minus 1, right? And then is that right? I feel like if that's right, it's a little bit too easy. But yeah, that's all the combinations, because you can only take from both sides, and this covers all the combinations. And then let me see, how about the AND case? So now I is 0, so we take I, right? And then j is where? Where is j? J is going to point into this, right? And then we take this, j at this, and go one more, and then we end. And then we just return res. Okay, take a look. Feel a little bit, I'm not 100% sure. Okay, so what do we have? We have 1, 2, 3, 4, 5, 6, 1, 3. This gives us 12. The next one is 2, 2, 2. This give us 2. Now give us 4. Next one is 9, 779, 779. This give us k is 7. This give us 55. Basically, we don't do anything on this one. In this case, I is equal to. In this case, it's the same. We remove 9, we plus 9. Yeah, that's fine. 1, 1000, and 1, and then k equals 1, and output is 1. The last one is 179, 80, and then 111, 200, 1, 3, 202. Let me add my test case here. I have a 1, 100, 1, 2, 3, doesn't matter, and then 10, and 90 will be, 90, and then we say we're going to take 2, right? We take 2, so the result shall be 101. Okay, next one here, we're going to change the car points, k. This is going to be dot max score, car point k. Reference before assignment. Oh, why does rest this? That is not correct. I think I added one more. Did I add too much? So we sum the first k, right? And then there's 0 to k minus 1. I say I is k minus 1, j at the end. Well, I logic is 0. Remove the front and plus the end. Right? So it's a 3. So 0, 1, 2, so it's be here, right? 1 plus 2 is 3. 3 plus 3 is 6. And let's take a look. Let's take a look. Don't guess. We're gonna print res here, and then each time we're gonna print. Let's print res card points I and card points j. Just make sure that everything is running correctly. All right, so start with 6, right? 6, and I have 3 and 1, and then 6 minus 3. That's not right. It should be 3. What is it? I is k minus 1. K is 3. It's 2. 0, 1, 2. Oh, I read it wrong. Here, that's the first one. 6 minus 3. No, minus 3 plus. Okay, I should do it here because like without. All right, so 6, 3, 1, and then 6 minus 3 is 3 plus 1 is 4. So if I do this, that'll be 4. So we result is still 6. All right, coming next one, we have 2 and 6. Oh, that's not res anymore. Ah, God, that's correct. We have a poo-poo here. So we have a res, right? And we also have a sum. Sum equals res. And res gonna equal to res and the new sum. Res here. Sum is gonna equal to s minus this plus this. There we go. Now we pass. Yeah, we can. The rest doesn't change. Rest will just stay at the max, but the sum has to change. Okay, let's run this. Let's see if there's any test cases that we have not considered. Oh, let's try some edge case. 1, right? So 1 element will be an edge case. And can we do 0? No, it has to be 1. Should be fine. Should be 1. Okay, try it. Pending, judging. Oh, it is. It's a simple question. We start from taking all k elements from the front. Then we swap out one of the front with one from the end. One from the front with one from the end. We do this until all k elements are from the end. We record the max sum along the way and return it as a result. Okay, yeah, this is simple. It's a simple question. It disguises itself as something more than what it actually is, but no, it's okay actually. It's okay. And we get 404 and 85% ranking. Alright, take a look, see if there are any other ways of solving this. I don't see any other way. It looks fairly straightforward to me. I'll keep sum, or we'll keep I and j. Yeah, I mean, it's possible that we can do a while loop. We'll do a for loop. Yeah, we can do a for loop, but it's the same thing. All right, it's the same thing. All right, we don't have a solution for this, but it's fine. It's fine. I think it's easy. It's labeled as medium. Well, it's an easy medium then. Looks like a contest, huh? Looks like a contest in the past. So it's LeetCode 1423. Sliding window. Is this considered sliding window? Oh, you have DP. Oh, you can do a DP. How do you do a DP? Oh, somebody said this question is a Google round 2 on-site question. It's very simple. It's very simple. Oh, look at this. We can save variable. We just need to go I minus I, very smart, and k minus I. Yeah. Everything else looks about the same. Yeah. Find a small subarray sum length of. Oh, interesting. Find the smallest subarray sum of length. Nice. True. I mean, it's the same concept, but yes. Maximum sum from front to end, which equals to the smallest subarray sum of the middle. And that's just a sliding window, right? That's just a sliding window. Front for I, we plus size plus I minus the front min array and the sum. Yep. DP. No, it's probably not DP. What's the DP idea? This doesn't seem to be DP to me. Now I rejected DP because the optimal solution of the previous one does not apply to the optimal solution of the next one, so it's not a DP. I don't know what this is trying to do. Don't think of. You know what? Let's try it. Let's try to think about what he's trying to do here. Okay, if k equals length, return. Okay, then this is ijk. If k equals 0, if k is 0, what's k? K minus 1. Oh, k is this. Return 0, as a result, is maximum card points I plus DFS. Oh, that's the idea. If I choose an I, if I include I, then it's going to be the maximum value of DFS I plus 1. J is at the end, right? So it would be, hold on, what are you trying to do? If I take, it's a sub, let me think. What you're trying to say is, want to find out the maximum sum of this configuration is the same as finding out the maximum configuration of starting on the first position to the end. That's when we include I, right? Okay, or we do not include I, we include J, which is at the end. So we do I and J plus 1. Oh yeah, yep, that's true. That is true. And he threw in a cache, trying to see if it works, but it timed out. Because it's O(n) squared, right? If you have I and J, it's O(n) squared. No, not O(n) squared, it's going to be each time you cross out 1 and you take the remaining, right? And then you take the remaining, that usually is OK squared. I think that's OK squared. And the K here, I think the maximum K can reach 10 to the 5th, right? So that is going to be timed out. All right, it's good. I still upvote this one. Yeah, I was trying to think about like how do we approach it with the DP. Yeah, that's how you approach it. When you have like two options, right? If you have two options, we take one and then we break down the problem to a subproblem, and we'll take the other one in the subproblem. Yeah. Maybe it's like better to think. I don't know. I mean, this is the thing top down, right? I was always trying to do, when I do DP, I try to think bottom up, and think bottom up. I say, oh, I don't think it can be done. See what other people have, other ideas. Yep. Is that person still using Python 2? Man, look at this. This is Python 2. Did have good drawings though. DP solution. Oh, this is a bottom-up DP, huh? Okay, let's take a look. Stores the total points when taking I cards from the left. Okay, taking I cards from the left. So I to this, DP0. Okay, so taking 0 cards from the left will be this. Oh, that's the same. That's the same. That's not a. I don't consider that as a DP. The other solution is a DP. This one is a DP, right? This one DP, but it timed out. Replace them. Yep, I think that's it. That's it. Oh, we have a DFS. Okay. Finding the height of the binary tree. I have a left. This plus DFS. Right. this. If not, comma, not this. I mean, passing this is not a right choice. But max. Okay, so we cache it. Oh no, it's end up with the same one, the same. That's not a DP solution, right? Yeah, you don't even call it DP again. That's not a DP. That's just a regular solution. But a regular solution, it came from DP, right? It came from DP. I don't know. But again, I think it's good to think about that solution, right? When you have this situation of two choices, right? How to break down two choices. I mean, it doesn't pass only because it doesn't pass only because of this, right? Only because of this. Wait, here, this. That's the reason why the DP with a cache doesn't pass. But it's all depending on the judge, right? The judge loosen the requirement, and then it becomes it can pass. Let's see, what's the high end? 500. Like I said, it's 400 to 500, so it's very short range. If it allows to all k squared, I think it will go up to what? Maybe I'll allow like maybe 1,000, and then it will pass. Anyway, good question. Good question. DP is solvable. It can be solved by DP, but obviously we don't have to. And I like the sliding window. That's another way of thinking. It's the exact same way of thinking. Well, I shouldn't say same way. Exact same type of algorithm, but it's from a different perspective. I like that too. Actually, I'm going to write it here. Another way to think. Actually, I'm going to also reference the person that wrote it. This one, right? So we can copy this. Another way to think is to find the minimum sum of a subarray using sliding window. Sliding window. The result will be the difference between the total sum and the mean subarray sum. Reference. Alright, that's it. That's it for today. Pretty good. See you guys tomorrow. Adios.